Hey guys, it's Mrs. Miss Moore. Just coming at you with some calculus for this week. This week we're going to look at some properties of integrals. If you noticed on Google Classroom, I posted our notes for the day. If you printed those off, it's going to make it helpful. If not, you can just follow along. You can always go and print those off later. Um, just watch the video as you do your homework, whatever, is going to work for you. But the first thing we're going to do is we're going to look at just what are the different pieces. Okay. The whole thing, if you know where you start and where you end, like last week when we did our Riemann sums, that whole thing is called a definite integral. And last week we were just trying to approximate it by using those left and right hands. Obviously, there were some that were over, some that were underestimates. What we're going to start getting into is how to go and actually figure out what is that true value. So some different pieces that you're going to see. Again, that whole piece is called your definite integral. If you know that your a value is smaller than b, which is how most of these are going to be set up, that means your a is your lower and your b is your upper. That little looks like a S, elongated S, that's your integral sign. That's going to say, hey, you have this function. You're actually trying to figure out what is its antiderivative, and we'll go and get that. But if I take the function I have and find the area underneath that curve, I'm actually getting what those y values are. So what we're going to be doing is looking at areas. Before we even go and do that, we're going to be looking at some properties, so this isn't going to be too bad this week. Your integrand is just what is your function? Okay, and then dx is going to be your variable of integration. If it said dt, that would just tell you, oh, the variable I'm using is t, or this just tells you what is the variable you're using. And again, I can go and say all this stuff is true if my a value is what's smaller than b. So make sure you have that written down somewhere. You can pause this video. You can go back and look at it later, but that's what I'm going to have there. And again, before I get into my properties, that's what has to be true. You have to make sure that your smaller value is what's in the bottom, and then it goes to your larger value. And again, I have this function. Okay, again, the fancy word is the integrand, but it's just saying this is a function. I plug in and try and find out what the area is. And again, this just tells you, oh, the variable you're using there is x. Okay, which again, it could change depending on what you have, but for right now, it's just going to be x. So let's start with this first one. If I know I start at A, it doesn't matter where A is, but if that's A, and then I end at C, so that's what this first part says, of this function. Okay, if I knew what its area was, so it doesn't matter what it looks like, it could look like this. Okay, so that's from A to C, I could go and get that area. Then, if I, again, this is where I start, which means if I start at C and I end at B, and again, it could look something like this. It doesn't have to be a straight line. It could be a curve because of where we're going. But that just says that if I have this area piece, which is what that part is, and if I have that area, then I can go and say, well, the whole area from A to B is me adding those two pieces together. The second one says that if I stop and start at the same place, well, if I stop and start at the same place, that means that there's no width, which means that that width is 0. What's 0 times anything? 0. So if you look at that and you see that your start and stop places are at the same number, that means that the area underneath that curve is 0. Okay. On this one, it looks sort of like this we had to start with, right? Except what's different? These are reversed. So if I want to go and switch those around, that's going to say take out a negative and then write from A to B of f of x. So that's another property that if you look at that and you see that your bigger numbers here and your smaller numbers up there, you reverse them and you put a negative out in front. Again, still the same setup, right? Still the same setup as before, but now I have some number. I have 2, I have 4, I have some constant. Then I can go and say, well, whatever that number is, I can multiply that by whatever that value is for the function. And this week, I'm going to tell you what that function's value is, okay? If I know that I have 2 different functions, but they're both starting and stopping the same place, I can go and split it up. I can say that the value for f of x from that stop to start and the value of g of x from that stop to start, I can add them together or subtract or do whatever it says with those 2 values. If it says add or subtract. So I can go and do that. So those are my different properties. Okay, got really 5 big ones there. So if I went and looked at some example problems, okay, and again, you're going to have some given information. It's going to say, if I start at 0 and I end at 3 of this function f of x, the area under that curve is 7. And then if I look at it from 3 to 7 of that same function, its area is 5. And so I have another function. Still looking at it from 0 to 3, that's area under that curve is 10. And from 3 to 7, the area under that curve is 2. Okay, so those are my different pieces. So in the first one, it says make sure I use f of x, which says use these 2 pieces. And it says, oh, I can use that property about, well, if I have that whole thing, I can go and split up into the pieces that I know. I know what happens from 0 to 3. And I know what happens from 3 to 7. So if I go and back up here and say, well, that value is 7, plus from 3 to 7 up here, that's 5. Well, what's 7 plus 5? 12. So it means that that value there is going to be 12. If it said, oh, I want to still look from 0 to 7, but now of g of x, I go and use this information. So if I look at it from 0 to 3, and I go and look at it from 3 to 7 of g of x, now I can go and add those together too. So from 0 to 3, its value is 10. And from 3 to 7, its value is 2. So, you know me, I just pick random numbers. That area is also 12. Okay, these will not always be the same. It just happened because I picked the same value. Okay. Then it says, well, look at it from 0 to 3 of these 2 functions. So that means I can go and split up. I can say, well, if I look at it from 0 to 3 of f of x, and I look at it from 0 to 3 of g of x, so from 0 to 3 of f of x, that value is 7. So I can go and say 7 plus from 0 to 3 of g of x, that's 10. So that value is going to be 17. If I go and look at it from, oh, still wanting me to add these 2 functions together, but now from 3 to 7. So if I look at it from 3 to 7 of f of x dx plus 3 to 7 of g of x dx from 3 to 7 of f of x, that's going to be 5 plus g of x, that value is 2. So 5 plus 2 says, hey, that value is going to be 7. Then if I go and look at 5, this one says from 3 to 0. That number's bigger on the bottom. So that means I got to do the trick of rewrite it. And when I go and rewrite it, I throw a negative out in front. So from 0 to 3 of g of x, that value is 10. So my answer there just ends up being negative 10. And that's it. If I go and say, if I start at 5 and end at 5, that means my width is 0. So that value is going to be 0, because anything times 0 is 0. If I go and look at number 7, and again, it's set up the right way from smaller number to bigger number. And I can go and write that thing where, oh, I have some value being multiplied by my function. So I can say 3 times from 0 to 3 of f of x dx. Well, from 0 to 3, right, f of x value is 7. So I can go and say, well, 3 times 7 is 21. Oops, sorry about that. So I can say 3 times 7 is 21. So that means that that area would be 21. Doesn't matter if it's a positive number in there. It could be -1/2. It could be -10. Just go and take that number out in front. On 8, that is really a 0. It's not trying to look like a 6 because we don't know anything about what happens at 6. So if it says from 0 to 3, and again, smaller number, bigger number, of g of x dx. So 4 times, well, from 0 to 3 of g of x, that value is 10. So 4 times 3 says, oh, that area under that curve would be 40. So it just says take my g of x, multiply by 4, goes and expands it. If I went and looked at it from 0 to 7 of g of x minus f of x, well, don't I already know what from 0 to 7 of g of x is? And I know what happens from 0 to 7 of f of x. I found those earlier. So if I go back and look at number 1, from 0 to 7 of f of x, that value was 12. So that's my f of x. That's going to be 12. And if I go back and look at number 2, from 0 to 7 of g of x, its value was also 12. So on this one, that area is going to be 0. Okay. If I wouldn't have already found those, I'd just go and do the same type of thing I did on 1 and 2. I'd say, well, what happens when I look at it from 0 to 7 of g of x in those two little pieces? And the same thing for f of x. It could be split among 2 pieces. It could be split among 3. It just all depends on what you have there. So just make sure that you know those 5 big properties, that if you have one big integral, you can say, oh, there's a stopping spot in the middle. I can go and add those together. If you go and look and you see that your stop and start place are the same, that means that the area under that curve is going to be 0. If I look at, the bigger numbers on the bottom of that function, I'm just going to put a negative out in front of whatever I have there. If I have a function that's being multiplied by some constant, pull that constant number out in front and then multiply by whatever your other value is. And then from, if I have 2 functions and they both have the same start and stop places, I can just go and add those 2 values together if it says add, or subtract those if it says subtract. Remember, you can always go back and look at these different pieces as you go and work through your homework, but you have a quick little assignment, 9 problems over these same properties, and then tomorrow we'll have some more work over these as well. Hope you have a great day. Bye.